are morphing CSS animations, replacing SVG frameworks in 2026. If you're still shipping heavy SVG animation libraries in 2026, you might be solving a problem the browser already fixed for you. For a long time, fluid animation on the web came with a hidden tax. If you wanted anything beyond simple fades or transforms, you had to reach for SVG or JavaScript-driven animation systems. That meant larger bundles, more complexity, and a constant performance trade-off. Developers accepted this because there was no real alternative. The browser simply was not capable of doing this work on its own. But that assumption is no longer true. Modern browser engines have evolved in a way that most developers have not fully internalized yet. CSS is no longer just a styling language. It is now a capable animation system with access to optimized rendering pipelines. And that shift is what makes morphing CSS animation possible. So what do we actually mean by morphing in this context? We are talking about smooth transitions between complex visual states, not just moving an element from left to right, but transforming its shape, its structure, and its visual identity in a continuous way. Historically, that required SVG path manipulation or heavy JavaScript interpolation. Now, the browser can handle much of that interpolation natively. Let's go deeper into what used to happen. When you animated with SVG frameworks, you were often updating path data frame by frame. Each update triggered work in the DOM. That work cascaded into layout recalculations, paint operations, and sometimes forced reflows. Even if you optimized your code, you were still operating inside a system that was not designed for high-frequency, complex animation updates. This is why performance would degrade under stress. Add more elements, add more interactions, add more complexity. Eventually, the system starts to break down. Frames drop, animations stutter, input feels delayed. Now compare that to how modern CSS animation is processed. When you define animations using properties that can be handled by the compositor, the browser can bypass much of the traditional rendering pipeline. Instead of recalculating layout and repainting on every frame, it can operate in a layer that is optimized for motion. This layer is often GPU accelerated, which means it is built to handle continuous visual changes efficiently. This is where the real shift happens. You are no longer pushing updates into the system. You are declaring states and letting the system resolve the transition. That difference sounds small, but it completely changes the performance profile of your application. Morphing CSS animation builds on this idea. By leveraging interpolation between compatible values, you can create transitions that feel organic and fluid. You define where something starts. You define where it ends. The browser calculates everything in between using optimized internal logic. There is no animation loop to manage. There is no constant state mutation. There is no heavy runtime overhead. And that leads to one of the biggest advantages, which is predictability. When you rely on native systems, you get consistent behavior across environments. The browser vendors have already optimized these pathways. They have already tested them at scale. You are building on top of something stable instead of layering your own custom animation engine on top of the DOM. Now let's talk about bundle size, because this is where the impact becomes very tangible. Every library you add to your project increases the amount of code that needs to be downloaded, parsed, and executed. Animation frameworks are often not small. They include utilities, fallbacks, abstractions, and features you may never even use. By replacing those with native CSS, you eliminate that cost entirely. Your application becomes lighter. It loads faster. It becomes more accessible to users on slower connections or lower-powered devices. This is not just a technical improvement. It is a user experience improvement. There is also a maintainability angle here that often gets overlooked. When your animation logic lives in JavaScript frameworks, it becomes part of your application logic. It needs to be maintained, debugged, and updated. It can introduce bugs. It can conflict with other systems. When your animation is defined in CSS, it becomes declarative. It is easier to reason about. It is easier to modify, and it is less likely to break unrelated parts of your system. Now, this does not mean SVG is going away. That is an oversimplification, and it is not accurate. SVG still plays a critical role in web development. If you need precise control over vector paths, detailed illustrations, or complex data visualizations, SVG is still the right tool. It is not being replaced. It is being repositioned. The key difference is this: SVG used to be the default for advanced animation. Now it is the specialized tool for specific use cases. For most UI-level motion design, the browser can now do the job natively. And when the native solution is faster, simpler, and more efficient, it becomes the new default. This is part of a larger trend in front-end engineering. Over the past few years, we have seen a shift away from heavy abstraction layers and toward platform-native solutions. Browsers are becoming more capable, standards are evolving, and the need for large, general-purpose libraries is decreasing in many areas. This does not mean frameworks disappear. It means their role becomes more focused. The same thing is happening here with animation. So are morphing CSS animations replacing SVG frameworks in 2026? The honest answer is that they are replacing them in the majority of cases where performance and simplicity matter most. Not everywhere, not for every edge case, but enough to fundamentally change how we approach animation on the web. If you are building modern interfaces, you should start with CSS. You should understand what the browser can do today before reaching for external tools, because every unnecessary dependency adds weight, complexity, and potential failure points to your system. This is really about thinking differently as a developer. Instead of asking what tool can I add, you ask what capability already exists. That shift leads to better decisions, better performance, and better systems overall. And if you zoom out, this is what modern front-end development is becoming. Less about stacking tools, and more about understanding the platform deeply enough to use it effectively. FrontEndSystemsLab is built around that idea. This channel breaks down what is actually happening inside the browser. We look at rendering pipelines, performance bottlenecks, system design decisions, and the underlying mechanics that most tutorials skip over. The goal is not just to show you how to build something, but to help you understand why it works the way it does, so you can make better decisions in your own projects. If you care about performance, scalability, and writing code that aligns with how the web actually works, you are in the right place. Thanks for watching FrontEndSystemsLab. Please subscribe for more under the hood content.